What's that factor into? I just had to tape a new one. What's the deal? 3x minus 5 or 5y? 3x plus 5y. Everyone all right? We're not doing anything crazy yet. All right, 5. Any GCF, 49 and 36. Anything? Well, 49, I'm only thinking about 7, really. 7 doesn't go into 36, so that's it. No GCF, but what do you know about 49 and 36? They're perfect squares, and there's 2 of them, difference of 2 perfect squares. All right, I'm just going to go totally random myself here. Here we go, 9. What do you want to factor that into? There you go. Nice job. All right, here we go. Number 6, no GCF. So let's do this. 22. What are we looking at here? For the 16a squared. Okay, 16. Let's start there. That's a perfect square for 4. A squared, perfect square for A. Got that. And now let's go to 9. 9 would be a perfect square for 3. And then B squared for B. And what about my signs? You got it. All right, now we get into the tricky territory. 225b squared minus a squared. Any GCF? No. Some of you are wondering, 225, that's a little out of my league. I don't know if that's a perfect square or not, and I don't blame you. All right. First of all, how can I tell if it's a perfect square or not? Everyone ready for their calculators? If you're wondering if a number is a perfect square, you can take the square root of it. Yep. So you can, and my calculator is not working, but you can take the square root of 225. Do you get a whole number? What are you getting? 15. So 15 is the 225 is the perfect square for 15. So I can go 15 and 15. But I got to put what with the 15 if it's 15, if 25b squared? B and B. And then what about for a squared? A and A. Plus and minus, or minus and plus, whatever floats your boat. You look at the next one, something's a little strange about the next one, right? Those aren't those aren't perfect squares, so I probably have to do what first? And you should always be looking for this anyway. GCF. Yep, there's a GCF you can take out. I believe we've already taken it out of 72 and 50 before. What? Kind of, but not exactly. Here we go, number 3. What's the GCF, 72 and 50? 2. So if I take out a 2, I'm left with 36 p squared minus 25. Good. How about 16? You want to try to factor what's left inside here? 16? So 36. 6 p squared. And then 25 would be 5. Yep. And I still have to bring down the 2. Yep. To fully factor it. Everyone doing all right before I let you go on your own after number 9? Okay, what do you think about 9 here? GCF? Yeah, me too. Of what? Okay, well, I'll take out a 2. What happens when you take out a 2? Ooh. Plus, wouldn't be plus. right? Because, oh, sorry, you're right, plus. Okay, here's the problem we have, though. What's the name of this method? What's the D stand for? Difference, which means you should be. Okay, so how can I change that? Instead of taking out a 2, take out a? And now what's that do to the signs now? Okay, so now I have plus 1n, okay, minus x squared. Now it's the difference of two perfect squares. Good catch there. And now don't get freaked out here. I know it's in a different order. So we're going to write it in a different order. Ready? 1 is a perfect square for 1 and 1. So those are going to go first now. X squared, then x. And what do I still know about the signs? Okay, so don't start getting freaked out because the x is to the right now. I just write it in a different order then. Okay. Let's see. Can I have you go? Is there anything I wanted to? Ooh, boy. Look at all those coming up, huh? Let's go to 14, everybody. 14. Let's take a look at 14. Let's see if anybody's on top of their A game here. Any GCF? Nope. That exponent's even. So it's a perfect square. It's a perfect square for what? X squared, right. And x squared. The 16. 4n. 4. What do you know about the signs? We'll do this awkward stare at each other until somebody has a thought here. Isn't this difference of two perfect squares again? Right? Perfect square difference. So what I'm asking you to do again is, yep, one more time. X squared minus 4. X plus 2 and x minus 2. Do not, oh, this is a huge trap everyone falls into. Oh, perfect square, let's factor it. You cannot factor this. Why not? What's the name of the method? Difference. That's not subtraction. Never fall into that trap when it's addition. I just bring it down. You see perfect squares and you're adding them, stay away. The only time I can factor it is when it's subtraction. All right? Everyone see that? All right, I'm going to make that more of a point here coming up. Whew, how about 15? Looking big time. Start at the bottom of the ladder. Looking for a GCF. Always start there. Do you see anything? A 3 and an x, right? Variables. Keep thinking variables. So yes, take out a 3 and an x. Let's talk. What's left inside? X to the third plus 2x squared minus x minus 2. I know we've been doing this a while. How many terms are still left in the parentheses? 4, and there's no more GCF. What should I try to do here? Group this sucker. You're darn right. 4 terms. Let's try to group it. Group. What can you take out of the first grouping? X squared. And what are you going to be left with? X plus 2. Stop before you just throw something out there. Think about what you would need to take out of the next one to be left with an x plus 2. A negative 1. And you're left with x plus 2. Let's finish grouping. What's in common? X plus 2 take out, and then what are the GCFs? X squared minus 1, and I still got to bring down the original 3x I talked about. Now we're getting hardcore. Come on. Look at what we just wrote up there. Come on. Hannah. Keep going. The x squared minus 1. That's a difference of perfect squares, isn't it? No? Yes? X squared is a perfect square, and so is 1, and you're subtracting. This is about as hardcore as we're getting right now. So 3x, x plus 2, one more time. What's that going to factor into? X minus 1 and x. Woo! That is some hardcore factoring right there. Look at what you just did right there. GCF, then we went to what? Grouping, and then we just went up with DOPS. 3 different methods in one problem. Go ahead, Emma. The quiz stops at when A is bigger than 1. There's not going to be any DOPS on there tomorrow. All right, I need you, Marco. No, we're not going that high, boss. All right, you wait till you're a junior if you get that far. All right. Okay. What? Too harsh? Too harsh? Too harsh? Too soon? Too soon? I didn't think so. Okay, get over it. All right, so what I need to see you guys do here, I need you to finish up 10, 11, 12, and 13 on your own or working with somebody around you right now. And I'll write the answers up here as you go along. Take your time, look for a GCF, and then see if it's different to 2 perfect squares. What's up over there, Hannah?
We can throw in an X.
Talk it over with each other, see what you end up with. Again, take a look up here when you're done with those couple and see if you're on the right track. If you're not, call me over. What's that? You're correct. But what do we always do first, Emma? right? Always rely, look for a GCF first. How are these three up here? Before we go to this last one, take a look. Oh, we're not even close to being done yet. Anything up here? 10, 11, 12, take a look. Take a look. Take out a GCF of all of them first. And then when you got to 13, hopefully you took out a GCF of X. And I was a little nervous about this one because I know you could handle 169X squared, but we've talked, you're not left with nothing. Left with a 1, which is also a perfect square. Some of you may have went to your calculator. Is 169 a perfect square?
Yes, it is.
For 13x minus 1 and 13x plus 1. Again, one last time. Why can that not be factored? It's a plus. It's difference of two perfect squares, not the sum. Difference. Questions? Okay, so I don't think there should be any issues with the homework tonight. Take your time. Remember, when you come through the door tomorrow, I'll give you a quick quiz number 2. Come on in today if you're having trouble. Come on in.